Yes, sir. Yes, sir.
How do you find the horizontal on
Asymptote?
Yeah.
So you're gonna look at the degree on top and degree on bottom. You're gonna compare them. All right. Yeah, the exponent.
Should a squared?
Yes.
That squared?
Yes. Yes. And you're gonna compare it to the one on the bottom.
Thank you.
You're welcome, baby.
What do you mean here?
Oh, there's no sheet?
Yeah, but thank you.
I don't have one then.
You can borrow mine if I'm finished with it.
Can I take a picture?
Take a picture of the positive and the negative ones.
Thank you. Thank you, sir.
We did, yeah. All right. We ready? Philip? Tyler, you ready?
Yeah.
Blake? Okay.
I think my calculations are incorrect, but I will try.
All right. What's cosine A?
Cosine A is square root of 5 over 3.
Cosine A is square root of 5 over 3.
Yes, sir.
I agree completely. We're getting that, Tyler, off the triangle, where you would do opposite over hypotenuse, and then fill in the adjacent side using the Pythagorean theorem. Blake, we good on that? Now, the reason why the quadrant becomes so important is because it tells me whether or not that piece is going to be positive or negative. And that makes a difference when I do the calculations. Does that make sense? Now,
It's going to be
sine B is
square root of 7 over 4.
square root of 7 over 4. Is it going to be positive or negative?
Negative.
It's going to be negative because it's in quadrant 3. It's going to be negative because it's in quadrant 3. Okay? We good? Now, as we look at sine A plus B is sine A cosine B plus sine B cosine A.
Yes.
All right, that's the formula for it. Okay? Now, here's the deal. Here's the deal. Here's the deal. I don't think these problems are that tough because, you know, A, you get to use your notes, so you have all the formulas written down. And grab some chips over there, too, if you want. And all you got to do is just find these values and then plug them in. Sine A is 2/3. Cosine B is negative 3/4. Sine B is square root of 7 over 4. Cosine A is square root of 5 over 3. So what do you get?
Negative square root of 35.
Negative 6 plus the square root of 35 over 12.
Yep.
Tyler, you good? You're good?
What? So if the sin b is negative square root of 7 over 4, why it becomes positive?
Oh, wait, no, it doesn't.
I made this mistake. Respectively, right?
I just, yeah. Really, I'm hungry and I.
You get your sandwich.
How am I going to get a sandwich? I got 4 problems to work.
You got to what they bring for donuts. At least
No, listen, if there's sandwiches left over, I'm totally taking them home. And when I say taking them home, I mean I'm taking them to my truck. Like, they're not going to make it home. Like, when the kids get home, they're like, "This, all you got Chick-fil-A?" Yeah, 6 sandwiches, actually. Don't be jealous. All right. People are like, "I don't think he can eat 6. Cosine A, cosine B, plus sine A, sine B, right?
Yes, sir.
All right. So now, cosine A, cosine B is square root of 5 over 3, negative 3 over 4. Sine A, sine B is 2/3, and then negative 7 over 4. So we got negative 3 square root of 5, minus 7 square root of 2 square root of 7 over 12.
Why does it look so not like an answer, you know? It is an answer, but it looks like incorrect answer, you know what I mean?
No, it looks perfect to me.
It looks perfectly, alright. It just looks too common.
There is a notion, Philip, that I call the eye test,
Yeah.
that all students put answers through. And you just look at it and go like this. Does that look right? And intermediate algebra, like, you know, when you're a younger math student, it's like, okay, I need it to be like 12. Maybe negative 4. Am I right? If you get like 18 over 37, you're like, oh, hell no. Right? The higher you go, the more you're willing to accept ugly looking answers. At this point in your life, Philip, there's as much you can rule out. Except like pi over 107. You go, I guess, yeah, probably not right. This, totally good. Okay?
No further questions.
All right. Further question. All right, let's go sine A minus B. Let's go cosine 2A. And let's go sine 2B. And we won't do or not to be. All right, so that's y'all. That's y'all. Jessica, if you're watching this online, know I love you, and we have a sandwich here for you that I'm going to eat later. Henry, anybody else in college algebra?
Mike and go.
What's that?
I said I remember how to do it.
Well, God, I would hope so. That was only 2 semesters ago. Henry, you're by yourself today, buddy.
Yay.
Boys on Asymptote, what is it?
I don't know.
Okay. So, we're looking at this, we're looking at this. If they're the same, we take the numbers in front and we write it as a ratio. So in this case, it's y equals 1. Okay? Vertical asymptote, we're setting the denominator equal to 0. So you're setting this equal to 0. You're getting x plus 2, x plus 5. And you're getting x equals negative 2 and x equals negative 5.
Oh, for the vertical one?
For the vertical, you set the bottom equal to 0.
Almost the x squared. Okay.
Set this bottom part equal to 0. Okay? For the X Intercept, you're plugging in, the top is equal to 0. So you're setting the top part equal to 0. That factors to x minus 5, x plus 1. Alyssa, I want you to notice. You remember doing this?
Yeah.
It don't go away. It just manifests itself next term.
Let's go.
All right? That factoring shows up in every course you're in.
Yeah.
All right. So for those of you hoping that, like, you know, you've seen the movie and now you don't have to watch the sequel. Oh no, it's like Hangover, baby. You gotta watch it.
You have to do the top one
Yep.
on to 0?
Yep.
Okay.
So X Intercept, you get 5 to negative 1. Y Intercept, you're going to plug in X is 0. 0, 0, 0, 0. You're going to end up with negative 5 over 10. See, Brandon, when you did it, we had stuff that looked like this, remember? And we said plug in X is 0. I don't give a shit what the equation looks like. In trig, they do X intercepts. How do you find it? Plug in Y is 0. How do you find the Y intercept? Plug in X is 0.
Right.
It's the same shit every single time. Just the formula gets more complicated.
How do you find the Y intercept again?
The Y intercept, you're plugging in X is 0. So 0 minus 0 squared minus 4 times 0 minus 5 over
Okay.
0 squared plus 7 times 0 plus 10.
And then just
This is 0, this is 0. The top is negative 5. This is 0, this is 0. The bottom is 10. We reduce that to negative 1/2.
and then whatever you just get after plugging in the X is what the Y intercept is.
Now the domain, Henry, we have to exclude both vertical asymptotes. We have to exclude both vertical asymptotes. All right? So we've got negative infinity to negative 5, union negative 5 to negative 2, union negative 2 to infinity.
Whoa, what?
We have to exclude these two numbers.
Yeah.
Negative infinity to negative 5, negative 5 to negative 2, negative 2 to infinity.
That looks like something we did.
Yeah, so what you did was just had one number. We just did negative infinity to negative 5, union negative 5 to infinity.
Right.
We just excluded one number in your course. Right? Remember doing that? We excluded the number, we cut it in half, and we put 2 pieces.
So
Same thing, except now we have 2 numbers to exclude, so we make a change.
we have to exclude the vertical one only. Okay.
Yes.
So that's all that space in between negative 5 and negative 2 is excluded?
Yep.
Will that be will the domain always exclude
Yes.
the vertical one?
Yep. Always.
Okay.
And I don't say always very often about anything. Always. So Henry, what I would like to do is maybe give you another one similar to this and let you try it again.
Can I take a picture of it?
Oh, of course you can. And Henry, I remind you that this is being live streamed to YouTube, so if you get home tonight, just go to my YouTube channel, it'll be on there.
Okay.
All right. So Henry, let's go here. Let's go y equals 2x squared. Let's go 2x squared minus 8 over x squared minus 9. Same ideas. Same ideas. Same, whatever it is, 5 questions. All right, here we go.
Let's go.
You ready?
Yep.
Elliot, you ready?
Sure.
Corey, you ready? All right. Top part. X plus 2, x minus 2. Over. Here. We're going to take out A negative 3, we're going to get x minus 2. Let me show you that in slow motion. Negative 3x plus 6. We're going to factor out the negative and the 3. It's common to both. And when we do that, negative 3 divided by negative 3 is just x. 6 divided by negative 3 is negative 2. Remember, when the x does not go in front, we just tend to move it around, but make sure you keep the signs with it. Okay? It's the signs that usually get people screwed up. Hope, did you have something?
No, I didn't have that.
Well, I know. I didn't know if you had a question about something specific, but you're good.
Yes.
I'll be there in a second.
Okay.
Now, what cancels?
X minus 2.
X minus 2, leaving you with x plus 2 over negative 3. Alright, x plus 2 over negative 3. Abigail, you good? You're in statistics, right? Alright, I'll be there in a second. Elliot, did you factor 2x plus 8?
Yes.
What did you take out?
I didn't take out anything. I actually made it x plus 4 and x plus 2.
Okay, there's not a squared though. In order to do that, you have to have squares. So what you should have seen is that 2 is common to both, and we would take out a 2. Okay? I think one of the biggest things we have, Elliot, is knowing kind of what type of problem factors which type of way. Right? It gets really confusing because there's so many different ones that do. Alright? On the bottom, what's common?
X plus 4.
This is the sum of 2 cubes. It is x plus 4.
And then x squared minus 4x plus 6.
So we use the x and the 4 to get x plus 4. That leaves us an x squared and a 16. So we got the x squared, we got the 16.
Negative 4.
We multiply those together and change the sign. The x plus 4 is common to both. And we got 2 over x squared minus 4x plus 16. We good?
Is that the final answer?
Yes, sir.
That is the final answer. That's the final answer. Elliot, you okay? Estella? Alyssa? I was running through all the people that I thought were in the class, and I think I know everybody now. Everybody's good? Anybody got to take a picture?
No. You give us a hard one.
They're all hard if you don't know the answer.
Yeah. How did you get a eraser?
It's in the other room. I ain't going to bring it over here.
Oh, true.
They won't get it back. Finest keepers around this school. Let's go 7x squared y over x squared minus 8x plus 12 divided by 21 x y to the third over 3x squared minus 18x. Then let's go 4 over x minus 7 minus 2 over x plus 5. Alright? Try those. Hey, I've still got more chips if anybody didn't get chips. And there's still more sandwiches. Scott, you sure you don't want a sandwich?
I'm good.
Have you ever had Chick-fil-A, Scott? Because I'm feeling like you must have never had it.
No, many times. No, probably.
Do you always have two values
Not always.
for vertical?
Not if it's x squared, a lot of times you will, but not always. If it's x squared, you will a lot of times, but not always.
Okay.
You know they're free, right?
Yep.
Okay, just want to make sure. And I know you were scanning the outs and stuff, so maybe it's not an issue, but
What?
they're free.
Yeah.
All right. We're here. We're here. First thing we got to figure out is what is p hat. P hat is 25 out of 120. 25 out of 120. Point what? 21. I thought you said 0.11, and I was like, nah, I'm pretty sure it's not that. 0.21. If P hat is 0.21, then Q hat is 0.79. All right, P hat is 0.79. Where's Marisol? Where the hell is Marisol when you need her? You all right?
Yeah.
All right, be careful up there now. It's hard out there on the streets. All right, part A. Part A, you got to draw this picture. We got 0.96 in the middle. Right, Abigail?
Yes, sir.
0.96 in the middle. On the outside, we have how much? 0.02. Right, 0.02. We get 0.02 because 4% is left over. It's 100% minus 96% is 4%. We cut that 4% in half. We get 2%. Now, you're going on the negative chart. You're going on the negative chart. You're going on the negative chart, you're looking at 0.0200. You won't find 0.0200. You'll find 0.0202. You'll find 0.0197. 0.0202 is closer, Chris.
Yeah.
So that value, when you look it up, is 2.05. So this is 2.05. Part B. You got to know the formula. Wilton, Ron, write this formula down. You're going to need it for the test. All right? P hat minus E is less than P, which is less than P hat plus E. And E is equal to Z times the square root of P hat, Q hat, over N. All right? Got to know that formula, but you can use your notes, so write it down. Okay? We call this, pay attention, margin of error. E is called margin of error. On the test, guys, it very well may say, what is the margin of error? Which is asking you specifically, what is E? Not asking you to do the whole thing, just what is E? Margin of error. Part C. Part C. 0.21 minus 2.05 times the square root 0.21 times 0.79 over 120 is less than P, which is less than 0.21 times the square root of point, oh shit, no, I'm just kidding. Okay. 0.21 plus 2.05 times the square root of 0.21 times 0.79 over 120. 0.2, 0.8 is 0.16, 0.16 is 0.4, 0.4 times that is 0.8, 0.82, 0.82 divided by 11 is about 0.06, 0.15, and 0.27.
I wrote 0.13 and 0.29.
Okay, close enough. I have to guess. Once I got down to 0.8 over 11, I was pretty much tapped out at that point. All right, 1 over 11 is 0.09. Knew it was less than that. Any questions on this? Will, you good? What's wrong? Shit. This is off the chart. All right. This 0.21 is basically the problem. It's this value, which we call x, is this value that we call n. So 0.21 is x divided by n, 25 over 120. All right. That gives you this number. Take 1 minus this number, and that will give you that number. Yep. It's 0.79. All right? And it's always 1 minus whatever that is, every time. All right? So, this formula requires you to know P hat, which is this, Q hat, which is this. This is P hat. This comes off the chart. On the negative chart, you're looking at 0.0200. You just won't find it. Do you still have those charts I gave you? Yeah. On the negative chart, look on the inside for 0.0200. You won't find it, but this is the one closest to it. And that value is 2.05. All right? And then from there, you just got to type it into your calculator. Part D, we're running out of space, but part D, if we continue to take samples of size 120, we expect 96% of the sample proportions to be between 0.13 and 0.29. Part E will be the same as we did in class. Part E will be the same as we did in class.
So it's always the same? Part E is always the same?
For that section, yes.
When will it, so like,
Next test, it changes. Okay? But for this test, for those problems, it's always the same, yes. All right? I'm going to give you another one similar to that. Let y'all try it again. Jasmine, yes.
Is E still in
Since n times p and n times q are greater than 5, the sample proportion is normally distributed, yes.
how do you know it's greater than
Well, n times p is 25, and n times q would be the remainder of that. So as long as both of them are more than 5, you're good. All right? You multiply 120 times this, and you basically get 25 back. N times q would have to be whatever the remainder is, so 95. All right? All right. I'm going to erase this part and leave the actual answer up. and give you another chance.
I gotta go. Bye.
Love you, Chris. Take care.
Thank you.
88 out of 100 people like Chick-fil-A.
Yeah.
12 people are liars. Alright, no, seriously. Use this to construct a 98% confidence interval for the proportion. Alright? Go. Philip, Blake, oh shit.
So it's 2/3 and square root of 5/3.
I'm getting rid of the first two, yeah?
Yes.
Alright. So now we have sine A minus B, which is
Sine A cos B minus sin B cos.
sine A cosine B minus sine B cosine A. And so again, here, Blake, notice that really the whole thing comes down to you finding these four pieces. Right? Like most of the students that I see struggle, they can never get to this part. Or they F this up so bad that now it doesn't even matter what the hell they put. Right? Because let's say you get sine 2/3 and you say cosine is 1/3. Well, hell, you F'd up now. It don't matter what the shit you put down. You got the wrong numbers to start with. Does that make sense? So, go to your triangle, use Pythagorean theorem if you need to. Just get the answer. 2/3, negative 3/4, minus. All right. So sine A minus B, sine A cosine B, minus sine B cosine A. So we got that. Now, cosine 2A. Cosine 2A. Cosine 2A, depending on how you do it. Now you can do it as cosine squared A minus sine squared A if you want. Or you can do 2 cosine squared A minus 1. Whatever you want to do, it's up to you. Blake, how did you do it?
Subtracted the 2 squares.
Say it again, please.
I subtracted the 2 squares.
Okay, so you did cosine squared minus sine squared?
Yeah.
So square root of 5 over 3 squared minus 2/3 squared, yeah? So we got 5 over 9 minus 4 over 9, 1/9. Yeah?
Yes, sir.
All right.
We gotta go with that.
Alright. Hey, y'all win the other night?
No, we lost round 2.
Oh, man. Alright. When do y'all start tournament? It's gotta be soon, right?
April 7th through 10th.
Okay. Alright, finish strong, guys. Hey, no donuts and questions on Friday. Not that you would come, but in case you wanted to.
What time?
No donuts and questions Friday.
Oh,
Alright, we'll see y'all. Have a good spring break. Alright, sign 2B is 2 sine B cosine B, which is, survey says, 2 times negative square root of 7 over 4, negative 3 over 4, yeah? So we're looking at 6 square root of 7 over 16.
3 square root of 7 over 8, respectively.
3 square root of 7 over 8. Good job. Any questions on that? Any questions? All right, trig guys, I don't think I'm going to be able to get back around to you again. All right. Well, what else do we need to go over? We did formulas. Formula for a tangent is very similar. It's all about getting the pieces, right? Like once you get the pieces, you just plug them all in. Like here's the interesting thing. I've never thought this section was that hard, although the test grades would certainly beg to differ. Because, you know, I look at students' test grades, I'm like, how the shit are you not getting this right? Like, it literally is a matter of getting all these pieces right. I think what happens is if you can't get these pieces right, everything else goes to hell. Does that make sense? Like, that's just kind of the general thing there. If we don't get these pieces, then all of the rest of it kind of goes to pot. All right. Yeah, I've only got 20 minutes, and I don't think I'm going to get through another full set. So, yes.
Is there anything else that we're going to have on the test this weekend?
We're going to go over, well, you know what? Let's solve those equations. I will give you one set, and then everybody else will just not get 3 problems. They'll just get 1. But let me show you how to do this, just a reminder again.
What is 55 mean squared?
Huh?
55?
No, 5 sine squared. 5 sine squared theta minus 4 sine theta minus 1 is equal to 0. And I want to solve this from theta equals 0 to 360 degrees. All right? Just a reminder of how to do that. We talked about it, but let's just remind her. All right, Henry. All right, Henry, here we go. We got 2x squared minus 4 over x squared minus 9. Yeah? If I factor the 2 out, it's common to both. So, degree on top, degree on bottom are the same.
2.
So the horizontal asymptote becomes y equals 2.
Yeah.
Y equals 2, Henry.
Y equals 2.
Vertical asymptote, set the bottom equal to 0.
So you factor that.
I factor that, yes.
Okay. So it's free and negative 3.
Yep.
Okay.
It is 3 and negative 3.
This is B.
All right. It is 3 and negative 3. All right. X intercept. How do you find the X intercept, Henry?
You get to set the top to 0. And
Yes.
It is,
Go ahead, I got you, I'm waiting. Did you get that or no?
no.
No, okay. You factor the top.
Mhm.
It's x plus 2, x minus 2. So that gives you x intercepts of -2 and +2.
Okay. I got a +2.
All right. Y-intercept.
-8 over -9.
So positive 8 9s, right?
+8 9?
Well, yeah, negative divided by negative.
Yeah.
Okay. All right. Domain. Domain. You got it? You want me to do it?
Negative infinity to -3, union -3, 3, union 3 to infinity.
Perfect. Great job, Henry. Excellent. All right. We're going to leave you there, Henry.
Okay.
All right. You take a picture, Henry? I'll leave it up there. You make a decision. All right. 7x squared y over x minus 2, x minus 6. Elliot, did you get that far?
I didn't do it like that.
All right. Well, you got to keep, change, flip, right, Corey?
Yeah, I did do that.
Keep, change, flip, right? So we keep, we change, we flip. So now this 21xy cubed goes on the bottom, right? Here, I factor out 3x, and I get x minus 6. Do we agree?
Yep.
Estella, you got that? Alyssa? What's wrong, baby?
Oh, no, I started it incorrectly.
Okay. Now we're looking to cancel. Now we're looking to cancel. X minus 6, x minus 6, cancel. 7 goes into 21 3 times. This 3 and this 3 will cancel. So what do I have? X cubed y over x y cubed times x minus 2. Do we agree? And now I have to cancel there. I have x to the third on top. I have an x on the bottom.
Is that x squared now?
That's x squared on top. I have a y on top, a y to the third on bottom. That's y squared on the bottom with the x minus 2. And this becomes your final answer. And this is probably not showing up. Lindsay, the struggle is so real right now. All right, Estella, let's pause here. You've done waited 45 minutes, going on an hour now. You have a question? Don't just take it, Estella.
Wait, what did you get the 3 under the 21?
So 7 and 21 I reduced.
Oh, okay, yeah.
I said 7 divided by 7 is 1, 21 divided by 7 is 3. And I double reduced, right? I went 70 to 21 and got 1 and 3. And then I said, oh wait, I got 3 and 3, I'll reduce those. So I kind of double reduced there. Corey, you good? Alyssa?
Okay, so when you crossed out the 3, can you explain that real quick? When you, yeah.
Okay, so I had a 7 here. So this is like 7 here, and then 21 here. 7 divided by 7 is 1, 21 divided by 7 is 3. Right? But then I had a 3 on top.
Oh, no, I'm sorry.
So this 3 and this 3 would then cancel.
I was talking about the final answer. Once you.
Okay, so I have a y on top, I have a y to the third on bottom.
Okay.
I have to subtract those exponents to keep the answer where the biggest exponent is.
Ah,
All right, that's taking you back into section 4.1, I believe,
yeah.
when we did that. Okay. All right. For this, are we good? Brandon, you good?
Yeah.
Elliot, we good? Estella, are you sure you're good? Here, up, over, 4x plus 5, minus 2x minus 7.
We should put that 6 on the top.
Say it again. 4x plus 5 minus 2x minus 7 over x minus 7x plus 5. Here I'm just using up, over. Here I'm using up, over. All right. (4x plus 20). Negative 2x, be careful here, plus 14. (4x minus 2x is 2x. 20 and 14 is 34. Now, notice that 2x plus 34 would factor, the 2 would come out, but then you would get x plus 17, which doesn't reduce, so you don't have to factor. All right? All right. We good? All right, and media, I'm going to leave you guys with that. Stats, here we go. Scott, you ready?
Yeah.
P hat
0.88.
is 0.88. Q hat
0.12.
is 0.12. Thank you, Estella. Thank you, Brandon. Thank you, Alyssa. Thank you, Elliot. Thank you, Corey.
Thank you.
This is 0.98. This is 0.01.
Yep.
All right. This is 2.33.
Yep.
P hat minus E is less than P, which is less than P hat plus E, where E is equal to Z times P hat Q hat over N. So 0.88 minus 2.33 times 0.88 times 0.12 divided by 100 is less than P, which is less than 0.88 plus 2.33 times the square root. 0.88 times 0.12 divided by 100. This is 0.9 times 0.1 is 0.09. Square root of 0.09 is 0.3. 0.3 divided by 10 is, so this would be 0.233 times 0.3 is 0.069. So that's about 0.07. Take it off of there, you'll get 0.81 and 0.95.
0.804 and 0.955. 0.80 and 0.96.
Yeah. 0.80 and 0.96.
Thanks for just ruining it, guys.
You're welcome. So on our scratch paper for the test, what if we don't write these? Will that be okay?
Say it again, please.
I already have the formula memorized, so if I don't write B on my scratch paper, is that okay?
That's fine. Just make sure you write when they ask you the margin of error.
Okay.
All right. Do I need to do D and E? We're good?
Is that going to be pretty much the only thing on the test, or is there like...
Oh, no, you got to do all of chapter 6, baby.
Okay, so chapter 6 is just like when you give us like something we have to find out on the chart.
Yes.
So it's pretty much that and this, and that's going to be...
Yes. Those are the two things you got to know.
So will there be continuity correction factors?
Yes.
How do we know when to include or exclude the value given?
You got to read the terms. If it says more than 20, you would say you don't want to include 20. You want to be higher than 20. If it says less than 20, you'd want to be lower than 20. If it's at least 20, it's 20 or more. So you got to read the term. I don't have a good way of telling you other than read the term and do it. All right.
Thank you.
You're welcome, buddy. Take care.
Thank you. Sorry.
Say it again.
Chapter 6. Alright, what was the 2?
Chapter 6 and then 7:1. So it's like 6:1, 6:2, 6:3, 6:5, or something like that. 6:6, something like that. Yes.
I'm trying to explain to her for P. Would it be easier to do P hat minus and then just, instead of writing the E formula, like...
Oh,
P
just
hat
put it where
minus
the E
P?
is?
Yes.
You could.
Okay. 'Cause I'm trying to...
I don't know if it's easier or harder, but you could definitely do it.
Okay.
All right, trig people. Let's solve this equation and I gotta get out of here. My kid gets out of school in 10 minutes. So we're gonna factor. This is 5 sine theta plus 1. Sine theta minus 1. That gives you the negative 4. Yes? This is sine theta equals 1. Sine theta is equal to 1 at pi over 2, which is 90 degrees. Right? Cosine is x, sine is 1. Scott, thanks so much for coming, man.
See you later. Take care.
Appreciate you. All right. Now, sine theta equals negative 1/5. Do we agree? Now, we're going to use a calculator. Now, remember that when you use the calculator and you do arc sine, you're going to get a number between negative 90 degrees and 90 degrees. So we have to adjust that because we can't say, negative 18 degrees or negative 84 degrees. We got to adjust that to be between 0 and 360, yes? All right, so what's arc sine negative 1/5? Just give me the number. In degrees, please.
Arc sine, negative 1 over negative 11.
Negative 11? Can we agree? I mean, I don't know. What is it?
Negative 11.5? Yeah.
Sounds great.
So it's gonna be 349.
So you would tack on 360 and you get 348.5. Right?
Yes, sir.
That's the one in quadrant 4. Now you got to come back to quadrant 3 and it's 191.5. Does that make sense, Blake? Because if you're in quadrant 3, then you want this angle to be 11 degrees. Right? So if this angle is 11 degrees, it's 180 plus the 11. If this angle is negative 11 degrees, then it's 360 minus the 11. get you back to that spot. Alrighty?
So how do we?
How do we what?
Because. Alright, I think because sign is negative, right?
Yes.
So we use the two negative quadrants. Quadrant
Yes.
3 and
Quadrant 3 and quadrant 4,
So we
yes.
have to find the value for quadrant 3 and quadrant 4. That's why
Yes.
it's 2 and 3.
And it's got to be between 0 and 360.
Yes.
You got to pay attention to this.
And for the first one where sign equals to 1, why we're not gonna? Oh, because it's just 9. There's no.
Yeah, there's no second value.
Alright.
Sine 270 would be negative 1.
I could get 191.
This is 11. This is 180. 180 plus 11 is 191.
Okay.
Okay. You guys good?
Mr.
Hey, listen, thank you guys so much for coming.
What answer do you want? Like the one-
Both. Both.
What section is that?
5, 6.
Did we cover that last time?
So that was the thing, right? Were you the one who said something about it?
Yeah, I was gonna ask you about that.
Yeah, so I'll go back and look at it.
Okay.
But you're correct.
Okay.
We covered solving arc sine in class, but not quadratics that are arc sine.
Yeah.
Okay? And so that was my mistake. But I may just put it on this one then. Okay? Because theoretically now you should have seen it.
Yeah.
And I know, Blake, we did it, but I think we only did it in a session like this.
So the thing is, the schedule doesn't say to study it.
It didn't say study for the last test. It says study for this one.
Yeah.
Yeah. No, I agree.
Okay.
I agree.
So we're gonna.
So I'm going to adjust it for you.
Okay. Thank you.
Yeah. No.
All right.
I'll take care of you.
Thank you.
Yes.
I told her if she doesn't understand it, just go to Lakeland and complain.
Sure enough. All right, y'all go get on that private jet. We'll see y'all later on.
So, Professor Drier, if you're doing a possibility correction version, it says at least 20, you would do 20 and a half, right? Or-
At least 20, you would do 19.5.
Oh, so when it says at least, you include the value?
Yes.
Okay.
When it says at least, you can have it. Take care, Henry. We'll see you.
Thank you.
Thank you, Mr.
Girls, I got one sandwich left.
Thank you, though. Wait, you leave it.
No. I'm gonna go somewhere else. Look, I gotta go pick up my daughter. We both can't have one sandwich. No, I gotta get my daughter a snack anyway. So one of y'all take it. It's totally okay. But whoever takes it has to take this too. Baby, you tell her whatever you want to tell her. No, what you say is, Mom, he doesn't let people who don't come to the session have a sandwich. And you have to stay for at least one problem.